Okay, in this video, we're going to do a factoring refresher. Quadratic equations can be solved by factoring as well. Use the problem below to refresh your factoring skills. So let's remind you how to factor before we go into solving equations by factoring. So first off, remind you how to factor out a greatest common factor. We find the largest value that is a factor of both of these. Let's start with our numbers. 12 and 18 has a GCF of 6. There is no K's in common, so that is our GCF. That's all we can factor out. Then we say 6 times what gives us the 12 is the 2, and I need a K there. And the 6 times what gives me a negative 18 would be a negative 3, and that's it. Number 2, GCF between 40 and 64 would be a 4, actually an 8. And then you do have x's in common. You always take the lowest power of x for your GCF, and you have y's in common. The lowest power of y there would be a single y. 8 times what gives you 40 would be a 5. I need 8 x's. I have 4 on the outside, so I'm going to put the other 4 on the inside. I need a y. It's on the outside. 8 times a positive 8 gives you the 64. I need 4 x's. They're all on the outside. I need 1 y, and it's on the outside as well. So that's the factored form. Number 3. 14, 35, and 7. GCF is 7 between those. I have m's in common. Always take the lowest power to factor out. That'd be m squared. 7 times 2 gives you 14. I need 6 m's. 2 are on the outside. Put the other 4 on the inside. 7 times a negative 5 is a negative 35. I need 3 m's. 2 on the outside. 1 on the inside. 7 times a negative 1 gives you negative 7. I need 2 m's, and they're both on the outside. That's it. 3, 5, and 8 has no GCF. It's 1 actually, so therefore we're going to leave it as is. I have a's in common, take the lowest power, which is a to the first. I have b's in common, take the lowest power, which is a b to the first. So that's 1ab is what I'm factoring. 1 times 3 gives me 3. I need 1a, it's on the outside. I need 2 b's, one of them's on the outside. Let's put the other one on the inside. 1 times a negative 5 is a negative 5. I need 2 a's. One's on the outside, one's on the inside. I need a b, and it's on the outside. 1 times a positive 8 gives you the 8. I need an a and a b, and they're both on the outside. So now I'm done, and you don't have to put that 1. Okay, the next section. When factoring, always look for a GCF, which we just did. Always look for the GCF first. So for every one of these problems, we're looking for GCFs. We're doing trinomials now. The way that we do these trinomials, where your a value is 1, we simply say we're going to do the trick of what adds to give us b, what multiplies to give us c. So quadratic trinomials, let's zoom in here, 2 sets of parentheses. First off, what multiplies give you x squared? It'll be an x and an x. And then you ask yourself, what 2 values add to give me 14, multiply to give me 45 would be a positive 9 and a positive 5, and that's it. Number 6, again, we're always looking for GCFs. There's not a GCF here, so therefore 2 sets of parentheses. W times W gives you the W squared. What adds to give you negative 15, multiplies to give you a 26 would be a negative 2 and a negative 13. Number 7, 2 sets of parentheses. C times C is C squared. What adds to give you 2, multiplies to give you a negative 48 would be a positive 8 and a negative 6. Number 8, 2 sets of parentheses. There's no common greatest common factor other than 1. N times n gives you the n squared. Adds to give you negative 1, multiplies to give you negative 72 would be a negative 9 and a positive 8. Number 9, 2 sets of parentheses. A times a is a squared. Adds, multiplies would be a positive 6 and a positive 6, which can be written as a plus 6 to the second power. This is what's known as a perfect square trinomial. That's a perfect square right there. Again, here's how you can identify perfect squares. If you can take half of this, multiply it times itself, and it gives you this, it'll always be a perfect square, and it'll always factor like that. This one is also a perfect square. Notice I can take half of negative 2 and I get negative 1, and negative 1 times negative 1 is a positive 1. So this will factor in into a perfect square as well. Negative 1 and negative 1 is a negative 2, and it multiplies to give me the positive 1, so I can write that as n minus 1 to the second power. Number 11. This does have a GCF, so we're going to factor the GCF out first. They share a 2. 2 times k squared gives me 2k squared. 2 times negative 8k gives me negative 16k. And 2 times a negative 20 is a negative 40. 2 sets of parentheses. K times k, and notice I just brought that 2 down. K times k is k squared. Adds, multiplies would be a negative 10 and a positive 2. Number 12. GCF here is 5, so let's pull that out first. You're left with a z squared minus 5z plus 6. Bring down the 5. Z times z is z squared. Add, multiply would be a negative 2 and a negative 3, and that's it. Okay, on this section, we're doing the exact same thing except for our a value here on ax squared, and that squared should be up there. Our a value is going to be a number other than 1. Like in this first case, it's a 2, so we use what's called the slip and slide method. And here's the slip and slide method. Take the number out front, and this is a shortcut, and slip it to the end, and multiply it by that number. Gives you a 36. Factor like normal now. 2 sets of parentheses. X times x is x squared. Adds, multiplies would be a negative 12 and a negative 3. Now the number that you slipped, which was a 2, you now take both of these values and you divide by that number. If it's divisible, you divide it. Like 12 divided by 2 is 6. If it's not divisible, like 3/2, you try to reduce it. If it's not reducible, you take that value that's on bottom and you slide it back to the front. And that is now a 2. A 2x minus 3, and that's it. And you can always multiply that back out, distributive property, and you will get that exact same value back. Next up, we're going to slip the 5 to the end, and that'd be a negative 240. That's going to be tough. 2 sets of parentheses, p times p, adds to give you 22, multiplies to give you a negative 240. And you can make a list of things that multiply to give you 240. That'd be like a 24 and 10, a 12 and 20. Here we go, a 30 and an 8. And that's going to give us that 22. So that'd be a positive 30 and a negative 8. The number that you slipped, you now divide by. P plus 30 divided by 5 is 6. 8 divided by 5 you can't do, and you can't reduce it, so therefore move the 5 back up front and slide it back to the front, and you get 5p minus 8. Number 15. Again, no GCF other than 1, so we're going to use slip and slide. Move the 3 to the end. Gives you minus 120. Factor like normal. H times H. Adds, multiplies. This will be a negative 24 and a positive 5. We are now going to the number that you slipped. We're going to divide by, and that will be an h minus 8. And you cannot divide this, or you cannot reduce it, so therefore move the 3 back up front, and that'll be 3h plus 5. Number 16. Slip the 12 to the end. We now have x squared plus 5x minus 24. Factor, x and x. Adds, multiplies, positive 8, negative 3. Divide by the 12 that you slipped, and that will not divide. So therefore, if it does not divide, we try to reduce it. Divide by 4 and 4 to reduce that to 2/3. Divide by 3 and 3 and reduce it to 1/4. Now the number that's on bottom is now slid back to the front, and that'll be a 3x plus 2, and this will be a 4x minus 1. Next one. No GCF to factor out, so therefore move the 6 to the end. Y squared minus 5y minus 126. 2 sets of parentheses. Y times y. Adds, multiplies. That'd be a negative 20. No, that's not right. A negative 14 and a positive 9. We slipped the 6, so now let's divide by it. 14 divided by 6 is not possible, so reduce it. Let's divide top and bottom by 2. That'll be 7 and a 3. Divide top and bottom over here by a 3. That'll give you a 3 and a 2. We now slide the numbers on bottom back up front. That'll be a 3y minus 7 and a 2y plus 3. Number 18. This one does have a GCF 16, 60, and 54. We'll factor out a 2 out of all those. You're left with 8m squared plus 30m minus 27. Now let's bring down the 2 and use slip and slide on the inside. That'll be m squared plus 30m minus, that's 160, 56, 216. Inside there, adds multiplies. That'd be an m and an m to give you 30 and negative 216. That's going to be a negative 12 and a negative 18. Actually, no, it will not be, because that won't give you the right signs. Let's try again. It'll be a positive 36 and a negative 6. There we go. Let me erase these values over here. So therefore, let's see, we moved the 8. So therefore, now let's divide by the 8. Will not divide, so let's reduce. So that gives you m plus, let's say we can divide by 4, that'd be 9 halves. Divide this by 2, that'd be m minus 3/4. Now let's slide them back to the front. So we now have 2 times 2m plus 9, and this will be a 4m minus 3. Okay, number 19. Step number 1, again, always look for the GCF. There's not one. This is going to be a perfect perfect square trinomial, because again, if you take half of this, multiply it by itself, gives you 36. If that's equal to this times this, in this case, since that's not a 1 out front, then it is going to be a perfect square. So you can factor it like that if you would like. To factor it like that, perfect square trinomials will always factor into, okay, 3x times 3x gives you this. What multipliers give you this will be a negative, or a 2 and a 2, or a negative 2 and a negative 2. Always go to this sign, so it'll be a negative 2 and a negative 2. But we can always use the same method. Slip and slide, move the 9 to the end. That'll be x squared minus 12x plus 36. You see the same perfect square here. That'd be an x and an x. Adds, multiplies, negative 6, negative 6. You move the 9, so now divide by the 9. That's going to be x minus 2/3 and x minus 2/3. Move the 3's back up to the front. That'd be a 3x minus 2 and another one. So 3x minus 2 to the second. Number 20. Look for, let's see, you can factor an 8 out of this, which actually turns this into one of the old type. Y squared plus 7y plus 12. So just because it has a number out front does not mean it's a slip and slide problem, because this one is not. Y times y, adds, multiply, positive 3, positive 4. Okay, set number 4, we're factoring difference of squares. Probably the easiest of the factoring. Difference of squares will always factor into conjugates. Here's what we mean by difference of squares. Perfect square, x times itself. Perfect square, 2 times itself. Difference means we have subtraction. Difference of squares always factor into conjugates, so you'll put a plus sign and a minus sign. Ask yourself what multiplies give you x squared to be an x times itself. What multiplies give you 4 is 2 times itself, and you're done. Conjugates mean that these are identical except for the plus sign in one and the minus sign in the other. Those are called conjugates. Difference of squares again, perfect square, y times y, 9 times 9. You have a difference, 2 sets of parentheses. Difference of squares factors into conjugates. Y times itself gives you y squared, 9 times itself gives you 81, and you are done. 23. 3x times 3x, 5y squared times 5y squared. So you do have a difference of squares. Conjugates, plus minus. 3x times itself gave you the 9x squared. 5y squared times itself gives you 25y to the 4th, and you're finished. 24. Mn times Mn, 7 times 7, difference. That is difference of squares. Conjugates, Mn times Mn, 7 times itself, and you're finished. 25. Always look for GCFs. We're going to factor out a 2 first. You're left with a 36r to the 6th minus s squared. 6r to the 3rd times itself, s times itself. So therefore, this is again difference of squares, 2 sets of parentheses, conjugates. 6r to the 3rd times itself gives you 36r to the 6th. S times itself gives you s squared, and you're finished. 26. GCF, you have a 2 in common. You have some a's in common. Always take the lowest power. And you have a b in common. 2 times 1 gives you the 2. A squared, you need no more a's. So in b's, you need no more b's here. So therefore, just 1. 2 times a negative 16 gives you the negative 32. You need 2 more a's. So let's put those, and you need 1b, and it's on the outside. So there you go. And what you're left with on the inside is perfect squares. 1 times 1, 4a times 4a, difference of squares. Bring down your 2a squared b, 2 sets of parentheses. Difference of squares, again, factors into conjugates, plus minus. 1 times itself gives you 1. 4a times itself gives you 16a squared.